In this video lesson, we will learn how to solve absolute value equations. So, when we're dealing with absolute values, what it amounts to is actually just checking several cases of linear equations, which we know how to solve pretty well. I'll explain what I mean in just a second. First of all, let's just remember how the absolute value of x is defined. It's defined as absolute value of x is x if x is positive, and it's negative x if x is negative. This means that if x has a negative sign, we get rid of it. If there is no negative sign, it's just the same. So absolute value of 0 is 0, absolute value of 1 is 1, absolute value of negative 1 is also 1. If there's a negative sign, we got rid of it. And same with absolute value of 2 and negative 2. They're both just 2. So now, let's solve some examples of equations. The first example will be pretty simple, just absolute value of x equals 3. What does x equal to? Well, actually, this separates into two cases, because the absolute value of x is sometimes equal to x, but sometimes it's equal to negative x. And that depends on if x is greater than 0 or less than 0. So really what we want to solve are two equations. One of them is x equals 3, and the other is negative x equals 3. While negative x equals 3 means x equals negative 3, and the other side is already solved. So this gives us two possible answers, 3 or x equals negative 3. So all we need to do is just plug these in and check it out. It's actually pretty easy to see that just, the absolute value of 3, since 3 is positive, it's just 3. And the absolute value of negative 3, since it has a negative sign, we get rid of it, is just 3. So obviously these two solutions work. And this is about how we'll do all the other examples of absolute value equations. So here's another one. Negative x plus 1 equals 2. Again, we have two cases. Either we just have negative x plus 1. I'll write that on the left. And then it equals a 2. Or we have to put everything in parentheses and put a negative sign in front of it. Negative x plus 1, all negative, equals 2. So the first one we just solve as a regular linear equation. Negative x equals 1, x equals negative 1. Then we solve the other one. First we just distribute the minus sign. We get x minus 1 equals 2. So then of course x equals 3. So here are two options for answers. Now we just have to make sure that they both work. So first let's plug in x equals negative 1. Negative 1 plus 1 is equal to 1 plus 1 is equal to 2. And then we take the absolute value of that, and since it's positive, it's just itself, 2. That's all good. Now let's plug in 3. Negative 3 plus 1 equals negative 2. When we take the absolute value, we get rid of the negative sign and we get 2 again. So both of these answers do work. They're good. All right. Let's do some more examples. In this next example, we'll take the absolute value of 3x minus 1, and we'll set this equal to the absolute value of x minus, let's say, 5. Alright, so in this case, we have two absolute value two sets of absolute value bars. Each of them has an x inside of it. So what do we do here? Because obviously there's two cases for each one of these. That is, 3x minus 1 is either itself or it's negative of itself, and x minus 5 is either itself or the negative of itself. So it seems like there's a whole 4 cases to check. But it's actually not quite that bad. We actually have 3 cases to check, or rather even actually just 2. These cases are, they have the same sign or they have the opposite sign. And what do I mean by this? What I mean is either we have 3x minus 1 staying the same and the x minus 5 staying the same, or if they both have a negative sign in front, then it's still the same equation. And if we put a negative sign in front of just one of them, then it's the same as putting the negative sign in front of the other one. So these are our 2 cases. We just solve these 2 options and we check if any of the answers work. Alright, so first we have 3x minus 1 equals x minus 5. That simplifies down to just 2x equals negative 4, or in other words, x equals negative 2. So here's our first answer. The other one, not quite as simple. We distribute the negative sign first, and then we move variables and constants to opposite sides, and simplify, and we get x equals 6 over 4, which is also equal to 3 over 2 in simplified form. So here are 2 options for correct answers. Now we just have to check and see if they actually do work. Alright, well, we have x equals negative 2. So we have 3 times negative 2 minus 1 and negative 2 minus 5. This all simplifies down to just the absolute value of negative 7 equals the absolute value of negative 7, which is also the same as 7 equals 7, which is true. So x equals negative 2 definitely works. Alright, let's check x equals 3 over 2. So we plug in 3 over 2 and we get 3 times 3 over 2 minus 1 on one side and 3 over 2 minus 5 on the other. Alright, well, 3 times 3 over 2 is 9 over 2. And then subtracting the 1 is the same as subtracting 2 over 2. And then we have 3 halves minus 10 halves, because 5 is the same as 10 halves. On one side we get the absolute value of 7 over 2, on the other we have the absolute value of negative 7 over 2. But both of these are actually just 7 over 2. So both the options for our answers work. So it's all good. Well, thank you for watching this video lesson. I hope it helped.